Our planet is constantly moving through a cosmic neighborhood filled with rocks and ice, left over from the formation of our solar system. Most of these objects, which we call asteroids, keep a very safe distance from us. However, every now and then, one of these space rocks ventures a little too close for comfort. Just last week, on October 1st, 2025, we had one such unexpected visitor. An asteroid, now named 2025 TF, zipped past our world in an incredibly close encounter. It was a stark and exciting reminder that the universe is a dynamic, active place, and that we are just one part of a much larger cosmic dance. The most astonishing part of this event was that we didn't even see it coming. Our planet is surrounded by a network of powerful telescopes, both on the ground and in space, all dedicated to spotting these near-Earth objects. But 2025 TF was like a ninja in the night. It approached Earth from the direction of the Sun, a notorious blind spot for our asteroid hunting systems. The Sun's overwhelming glare makes it nearly impossible to detect small, non-luminous objects heading our way. It wasn't until hours after it had already passed us that astronomers finally spotted this cosmic traveler as it moved away from our planet. The first official detection came from the Kitt Peak Bach Observatory in Arizona, nearly 6 hours after the asteroid had made its closest approach. When astronomers reviewed earlier images, they found that the Catalina Sky Survey had also captured it about 2 hours after its flyby. This delayed discovery highlights a significant challenge in planetary defense. While we are very good at tracking large asteroids that could pose a global threat, these smaller, city block-sized or even car-sized rocks can sneak up on us. The story of 2025 TF is a perfect illustration of why we need to keep improving our detection methods to cover all possible angles of approach. This close shave was not just a scientific curiosity, it was a genuine surprise for the astronomical community. Imagine playing a game of cosmic dodgeball where you only see the ball after it has already whizzed past your head. That's essentially what happened on a planetary scale. The event created a buzz among scientists and space enthusiasts alike, serving as a real-world exercise in tracking and characterizing a newly discovered object. It reinforces the idea that space is not empty, but filled with countless objects, many of which are still unknown to us, zipping around on their own orbital paths. So, just how close did this asteroid get? The answer is truly remarkable. Asteroid 2025 TF passed over the icy continent of Antarctica at an altitude of only about 420 kilometers, or roughly 260 miles. To put that into perspective, that is closer to the Earth's surface than many satellites, including the International Space Station, or ISS. The ISS orbits our planet at a variable altitude, sometimes dipping as low as 370 kilometers and going as high as 460 kilometers. This means that for a brief moment, this chunk of space rock was flying through the same region of space where astronauts live and work. This encounter officially goes down in the record books as the second closest non-impacting flyby of an asteroid ever recorded. It was a near miss of epic proportions, bested only by a similar event in November 2020. On that occasion, an asteroid named 2020 VT4 came even closer, passing by at a breathtaking altitude of just 370 kilometers, about 230 miles. These events are incredibly rare, but they show that our planet's gravitational pull can sometimes snag these small passers-by and draw them in for an exceptionally close look before flinging them back out into the solar system on a slightly altered path. The asteroid itself, 2025 TF, is a member of the Apollo group of asteroids. These are space rocks whose orbits cross Earth's orbit, which is what makes them potential candidates for close encounters. It was traveling at an incredible speed of about 20.9 kilometers per second, which is almost 75,200 kilometers per hour, or 46,700 miles per hour. At that velocity, it could travel from Los Angeles to New York in just over 3 minutes. This tremendous speed is why even a small rock can carry a huge amount of energy, and it's why we pay such close attention to them as they navigate our solar system. Fortunately, there was never any danger of this particular asteroid colliding with the International Space Station. Space is, after all, incredibly vast. Even when two objects are at the same altitude, the chances of them being in the exact same place at the exact same time are infinitesimally small unless they are on a direct collision course. The flyby of 2025 TF was a beautiful, fleeting event, that gave us a front-row seat to the intricate orbital mechanics that govern our solar system. It was a close pass, but from a safe enough distance for us to simply watch in awe. When you hear about an asteroid coming closer than the ISS, your first thought might be about danger, but in the case of 2025 TF, there was absolutely no threat to anyone on Earth. The reason for this comes down to its size. Scientists estimate that this asteroid was only between 1 and 3 meters in diameter, which is somewhere between the size of a microwave oven and a small car. In the grand scheme of cosmic objects, that is incredibly tiny. Our planet is hit by objects of this size several times a year, and they rarely make any impact on the ground. So, what would have happened if 2025 TF had been on a direct collision course with our planet? Instead of causing a catastrophe, it would have put on a spectacular light show. Upon entering Earth's atmosphere at such high speed, the immense friction with the air would have caused the rock to heat up and glow brilliantly, creating a stunning fireball or bolide. This streak of light would have been far brighter than the planet Venus in the night sky, easily visible even during the daytime. It would have been a dazzling and completely harmless natural firework display for anyone lucky enough to see it. As this small asteroid burned its way through the atmosphere, it would have broken apart into smaller and smaller pieces. Most of its mass would have vaporized completely, turning into a trail of dust and smoke high above the ground. It is possible that a few very small fragments, perhaps the size of pebbles, could have survived the fiery journey and reached the surface. These tiny remnants are called meteorites. Finding one would be like finding a needle in a haystack, but it would be an incredible scientific prize, a piece of an asteroid delivered right to our doorstep. This scenario is not just a theory, we have seen it happen before. The most famous recent example is the Chelyabinsk event in 2013, when a much larger 20-meter asteroid exploded over a city in Russia. That event created a shockwave that shattered windows and caused injuries. But even that much larger rock did not create an impact crater. Asteroid 2025 TF was many times smaller and would have resulted in an event far less dramatic. It serves as a great example that when it comes to asteroids, size really does matter. And in this case, small size meant no danger. The surprise visit from 2025 TF is a powerful lesson in the importance of planetary defense. It reminds us that our work to find and track near-Earth objects is a critical task for the long-term safety of our species. While this particular asteroid was harmless, we know there are larger asteroids out there that could pose a genuine threat. We have found most of the giant, so-called planet-killer asteroids, but there are still thousands of medium-sized ones, large enough to destroy a city, that remain undiscovered. Finding them before they find us is one of the grand challenges of our time. Every close flyby, whether we see it coming or not, provides valuable data. By tracking 2025 TF after it passed, scientists were able to calculate its orbit with greater precision. We now know it will not be a threat to Earth for the foreseeable future. Its next close approach in 2087 will be at a very safe distance of about 8 million kilometers. Each observation helps us build a more complete catalog of our cosmic neighbors, refining our understanding of their orbits and allowing us to better predict any future risks. It's like building a comprehensive traffic map of the inner solar system. This ongoing effort requires international collaboration and continuous investment in new technologies. We need more observatories, like the upcoming Vera C. Rubin Observatory, which will be able to scan the entire sky every few nights. We also need to develop more space-based telescopes designed to spot asteroids coming from the direction of the sun, closing the very blind spot that allowed 2025 TF to sneak by. Missions like NASA's DART, which successfully changed an asteroid's orbit, show that we are also developing the tools needed to act if we ever do find an asteroid on a collision course. Ultimately, the sky is not falling. Events like the flyby of 2025 TF are not a cause for alarm, but a reason to be curious and proactive. They are a call to action. By continuing to watch the skies, to discover these objects, and to understand their paths, we are taking responsibility for our own future. We are the first generation of humans with the technology to protect ourselves from a significant asteroid impact. It is our privilege, and our duty, to use that knowledge to ensure our planet remains a safe and habitable world for generations to come. Let's keep exploring.